we see the longitude going from the east at the bottom and Moscow in the far east, so to say, of the map at the top. And then you see some interesting things, because on the map the green line is just as if there's a march and they just moved along that line. But in the diagram you can see that it's interrupted for a very long time. So at a certain moment in time the troops were stationed there and nothing happened. And if we then again look at a different perspective, here we see again in the diagram time, and we see the height, in this case the number of troops he had at that moment in time. But what is interesting here is the gap again in the diagram. So somewhere in the middle is this big gap, somewhere in October. And that's strange. What happened? That would immediately question. And because that's also the purpose of these visualizations, that you start your visual thinking, as I said, that you get curious, that you want to ask questions. So what happened? And then it proved that Napoleon stayed this period for a month in Moscow. So again, if you look at the map, it looks he went from Eastern Europe to Moscow and back, as in a single path, a single trip. But no, he stayed for a month in Moscow, something you don't see in the map, but which you will see if you select an alternative visualization. So that's, I cannot strongly enough emphasize that it's in an exploratory environment important that you take different looks at your data, because that can inspire you, that can give you hints to solutions. Just a few other quick looks. This is a 3D version of the map. The height shows you the number of troops. This is the same, but now these heights and troops have been animated, and you see that during time he's losing people. Now you should realize one thing in this animation is that time is not progressing according what we see, because these are just snapshots of the different blocks put together. So it gives you the trend, but it doesn't show you that he stopped in Moscow for this month, because there is no link between, let's say, this animation time and real world time. Something to realize if you see an animation, by the way. So with any complex graphics, you should always ask yourself the question, what do I see? What has been mapped and how has it been mapped? Because there might be some tricks hidden, so to say, not on purpose, but you have to realize that certain choices have been made. Now, another interesting way to depict the data is to use the space-time cube. In this case, the horizontal layer in the cube shows space, the map as we know it, and along the z-axis, so the height, time is passing. So what we see here is again the path of Napoleon, and when lines are vertical, there is no movement. So here again you could detect that for a month in Moscow there is no movement, and that's where he stayed. Now, again, let's look at a few examples. So here we see on the bottom left the original map, and some people have written books about this problem, and they have described the path, and on the lower left I created a map of a certain person who followed this trip, and that's his particular path, and that again has then been depicted in this space-time cube. So again we see an individual moving during this campaign, and you can see where he stopped, where he stayed, and where he went. So the space-time cube again is an alternative visualization of this particular map. And again, if you use it, because again we see another one, but now with a number of troops in there, we can see that this period in Moscow, which is not visible in the ordinary map, is very much visible in the space-time cube. So again, it's not to advocate that the space-time cube is the solution for everything. I mean, any alternative, like the diagram I showed before, they might reveal these patterns. Now, telling all this, you should also realize that this is just a very simple example. In the beginning I was talking about lots of data, and again this is a small data set, but it's being used trying to explain the purpose of this geovisualization. Here again, a few alternative examples. This again is a detail from the campaign, such a military map. And here, in the circle of the space-time cube, it happened. And here it is depicted in the space-time cube. It's a bit chaotic, which means that, again, this map is not for presentation purpose, but for exploratory purposes. It is an interactive cube environment. And the blue lines represent Napoleon, and the red lines, the Russians chasing Napoleon. And the idea was to have a look at how the terrain might have influenced the movements. Again, it's not the best graphic, so to say, but in some situations it might be helpful. Okay, now I have to ask my hosts about time. What I might do is skip a few slides from the theory and just address the example, because by the example I might show you what it is. And the material is available online anyhow, so yes? Okay, so basically the idea of this geovisual analytics is that it is dealing even more with unknown data. So basically it's related to a new development called visual analytics, and that's defined as the science of analytical reasoning facilitated by interactive visual interfaces. And here you could also read by maps when it's a geo problem. This website, this web link brings you to that book. It tells you all about it. It's downloadable for free. It's a wealth of information. So again, you might have the information. But a very interesting motto is detect the expected and discover the unexpected. So what does it mean? It means that you look at your data, you might be familiar with part of it. So if your tools, maps, analytics, show you what you know, then you know, okay, it works. And by going further, you might discover other patterns, and that is then this discovery of the unexpected. Now, here I skip a few slides. Don't worry. It's all due to time. And I would like to bring you to this particular example to analyze certain data. So what we will do is we will look from a geo perspective at running data. So many people do some running for exercising, and it's also serious sports business, and people have collected all kind of data, and they might see certain patterns which are of interest. Now let's look at this particular run. It's represented run up a stair. You might